Hello, everybody. Welcome to the next presentation from the Scientific Coalition of UAP Research. And our guest today is Peter Reali. Peter has a BS and an MSEE from the University of California, Berkeley. He's had a long career in the Silicon Valley as an electrical design engineer and manager of engineering projects. His specialty was in telecommunications and network and information technologies. He's a founding member of the SCU, and he's worked on a lot of great projects, including the Nimitz report that you can get at the website. But his talk today is going to be a statistical treatment of the Drake equation with the implications for understanding of the Fermi Paradox and some hypotheses about UAP technology. So I'll bring Peter on. Hello.
Hi there.
All right, and it is all you.
Okay,
Thank
so
you.
I share screen, right?
Yep, go ahead and share your screen. I'll bring that up.
Okay.
And do get in your questions as we go along. We will save the questions until the end of the first part of the presentation, then we'll get into your questions. But do ask your questions. We've got Martin Willis from Podcast UFO in the background helping us, and he and I will be collecting those questions for you all so we can answer those questions once we get to that section.
Okay, do you see my screen now?
Not yet.
Okay, let me go.
It might even help if you put a Q or write the word question before your question to help Martin and I spot it as the conversations go on. But thank you all for joining.
I have application window open here.
Okay. And then it should give you...
I'm not seeing all my applications, so I'm not quite sure what's going on.
Might have to restart it.
Restart the share screen or what? Okay, let me go your entire screen. Chrome tab, no. Application window. Well, it was working before. I don't know what.
Is the PowerPoint open, or was it?
Yeah, it's open. Yeah, and when I put it up, it's on. If I go,
you could choose the entire screen option, and since you're going to full screen it, that should work.
Entire screen. Okay.
Yeah,
I'll do that. How's that work? You see anything?
Not yet.
Okay, I'm in it right now.
I don't see it yet.
You said, should I go out again and come back in?
You could try that.
Leave the studio and...
Sure, that would be fine.
Okay.
And I will entertain everybody, I guess.
Okay.
So, those of you who are in, thank you very much. We'll get started in just a second. Of course, we practiced just a second ago, but as it goes with technology, something is happening. But we are doing these lecture series in lieu of a conference because, of course, of COVID. We would have had a conference this summer in Alabama again, but that wasn't able to occur. So we've been trying to bring some of our speakers who were going to speak at that event to do some presentations here. They're kind of shorter presentations. We are working on a new event for next year, and we'll have information out about that once that gets further along. But a lot of these presenters who we were planning on presenting this year will be presenting then, including Peter, and you'll be able to see some of these people live and ask questions live, and those will also be bigger versions of these presentations.
Okay, I'm back in, and I'll hit share screen again, and share screen. Okay. Application window. Geez, I'm not seeing it. Let me.
That's so strange.
Let me close some of the stuff that's there.
Okay.
Let me close this.
But I think what's really unique about the SCU, of course, is that we are advocating for science when it comes to investigation of the phenomena and that's our big question is, what is behind the UAP phenomena, and can science figure that out? And that's what we're working on. And I think that's really important right now because, we've heard a lot about government investigation of UAP. However, they have not shared really how they come to the conclusion, such as the Navy determining the Nimitz videos, the famous videos that were in the New York Times were actual videos of unidentified objects. Well, how did they come to that conclusion? They use some science somehow, but they're not sharing that with us. That's why Peter and Robert and Kevin Knuth and others with the SCU did that investigation to figure out what they could from public information. But of course, that's what the big goal is we need to get that data that the military has to scientists to investigate in a public manner. Still having problems?
Yeah, I still am. I'm not.
I wonder if you'll have to restart your computer or close your browser and open it,
All right, I'll do that.
And try maybe even closing the program and opening it.
Okay. I apologize.
Oh, no problem. Also, we do have some other people from SCU in the chat. And so if anybody does have any questions, go ahead and post those about the SCU and what the SCU does. And you know what I'll do while we're waiting is I want to show you all the website. So I'll share my screen. And I can see Peter coming back. Actually, let's go to Peter. He's back.
All right. Now let me go share screen.
It's funny because, even on mainstream news, you see them having these sort of issues.
I got it.
All right.
Okay. So there's I got the application there.
All right. I see it popping up. Here it is.
Okay. So let me get this started here.
Thank you, Zachary. Zachary says he loves our work.
Okay. Let me go back up. All right.
Okay, here we go. So all you, and then I will full screen it so everybody can see everything on the slides.
All right.
Okay, you're all set.
Okay. Thank you, everybody. My name is Peter Reali, and I'm, as Alejandro has mentioned, I'll quickly go over my background. I'm a degreed engineer, a master's in electrical engineering, worked in Silicon Valley many years, and retired now. I'm retired in Boise, Idaho. And I'm a member of the board of directors of the SCU. And I might just say, it's a little about my interest in UAPs. Over many years, I've been interested in, these reports because they seem, they're incredible reports from credible people. And it just seemed, but I never had time to investigate this. I had my career and the usual stuff that people have. But when I retired, I finally found the SCU, which I want to apply science to it. I want to, we treat this subject in a scientific manner and not in an entertainment manner or sensational or any of those kind of things. The SCU would like to get the scientific community interested in investigating this phenomena because it is, I'm convinced, a real thing. And so I want to just mention how I define a UAP. I define a UAP as not just lights in the sky or unexplained events, but machine-like technology that has characteristics beyond anything that some current science is capable of. And that's basically how I'm looking at it. And in this study, which is very speculative, I'll put that, but it does have some, at least, mathematical and scientific techniques applied to it. And what I'm trying to do is I'll explain the Fermi Paradox and the Drake equation and those kind of things, which probably many of you know already. But the way I'm tying them together is, how would we explain the well, let me move forward here. Let's start with the Fermi Paradox. Many people have heard of the Fermi Paradox, and they just say, well, where are all the UFOs? But what was really behind the Fermi Paradox was the size of the galaxy is about 105,000 light years, and it's close to 13.8 billion light years old. Well, not light years, 13.8 billion years old. And in that time, even traveling at small percentages of the speed of light, you could traverse the galaxy like if you were 0.01% of the speed of light in 1,300 times, and or 130, or a hypersonic missile, which is about 3,600 miles an hour, could do it in 7 times. Now, that's ridiculous. I'm not saying that's what happened or anything like that, but it just points out that any civilization that was, or species that was, there are probably many intelligent life forms in the universe. I believe that, and many scientists do as well. There would have been plenty of time for them to slowly hop between stars, and over that time, we should be seeing. If we look out into space, we ought to be seeing a lot of evidence for this kind of that this happened, and there should be many thousands, millions, billions of years. The universe is it's 30.8 billion years old. Some of the stars in the Milky Way, our galaxy, are close to as old as the universe. So there could, if life formed there could be entities that are billions of years older than we are. So the paradox is, where are they? They should be hard to miss. And what I propose is we may be thinking we may not be thinking correctly about this. Excuse my. Okay, in this analysis, I have quite a few assumptions here, and one of the big ones is that why we're not seeing them is that after a certain period of time, which here I show as lambda, which I arbitrarily assume about 500 years. This can be expanded to longer or shorter depending on, but in this particular study, 500 years. I have kind of a mental image of why I picked this, but it's not in concrete. Any species beyond 500 years will become less interested in species that are less advanced than themselves. And not only that, but their technology, they may become very hard to detect. And the second one is, interstellar travel is a natural result of advancement in science. And this may sound preposterous to people, but I just think that it's going to be no big achievement for fairly advanced civilizations. This will just come out of developments in physics and as we go on. And I kind of take you say 500 years, well, that isn't very long, but I've been influenced by Ray Kurzweil, who's written many books on artificial intelligence, but he presents why science is expanding exponentially, and we tend to think linearly, but exponential expansion is very powerful. And so the third one is I've come up with a modification to the Drake equation, which I, with hubris, call the R equation, and I'll talk about that more. Lifetime here does not mean a civilization destroys itself or dies out, but moves on and stops communicating for various reasons, and I'll talk about that too. The lifetime of an intelligent species is a result of mathematically, the lifetime of an intelligent species is a result of multiple independent factors, and you can model this with the probability distributions as a result of a major theorem in statistical and probability mathematics called the central limit theorem, which I won't go into, but it's very powerful and used all over the place. 6, this paper is being used for the. In this paper, I'm using derivations of Frank Drake and Claudio Marconi, who estimated the number of communicative technological civilizations via radio. Now, I'm making the assumption that if their communicating via radio. They're also will also be interested in space travel and going around the universe. So the other two things are kind of two other. Actually, they're fairly powerful. Having no other examples to go on, I invoke the cosmological principle, which is used in physics all the time and astronomy. It makes the assumption that the local laws of physics and those kind of things are the same throughout our galaxy and probably throughout the rest of the universe. The second one is mediocrity principle, and that is our solar system is a typical example of an intelligent life-producing system in an average sense, meaning that we're not special, and there's a lot of history on why we always thought we were special. We're probably typical, and that there'll be many other species that have evolved similar to us. Now, the Drake equation is, it's basically uses 7 independent probability estimates. And I keep 6 of them, and I modify the 7th one, which is the communicative lifetime of a species. And that's a fundamental approach in my analysis here. And a couple of the constants I modified, I seemed a little bit too optimistic to me, and I put a range. I did a range from their values down to about 1/10 of their values in my final derivations here. And what I do is derive a number of planets or species, or however you want to categorize it, that have technologies that are within 500 years of us. They may be right on all the way from very, very at the same time as us, all the way to 500 years of advances in technology. And not that that stops or anything. They may keep advancing, but I think beyond that time, they're going to lose interest. We may not see them anymore. Okay, this is basically a table of the Drake parameters, and I'll just list them off as number of stars in the universe, fraction of stars with planets, fraction of planets that have the potential to support life, fraction of planets that could support life and actually develop life, fraction of planets with life that actually go on and develop intelligent life civilizations, technology, fractions of civilizations that develop technology and release detectable signs of their existence in space. Well, the final one is the raw, multiplying these together is the raw planet count. And current, I have its 2020 values, is they estimate that there's technological civilizations in our galaxy would be from about 2 million to about 100 million, which is a lot of, but why don't we see them? So, the model for the development of intelligent life, in my development here, I started thinking about how we might model this. And the estimated age of the universe is about 13.8 billion years. Earth is about 4.5 billion years old. And the age of life on Earth is about 4.28 billion years. And since planetary formation is really unpleasant for life, it took about 220 million years for life to start on Earth, and 4.28 billion years to evolve to its present form. Now, actually, 220 million years is a very short time in formation, and I think that's really probably very encouraging that there's going to be life all over the place in rather unpleasant. Will develop in rather unpleasant situations all over the place. I think life is very abundant in the universe. Not all of it, technological or super intelligent, but a lot of it will be. Okay, so I'm using the figure of 4.7 billion years as a typical time for technological and intelligent life to evolve. I call it an epoch. Given the current estimated age of the universe, there would be about 3 complete cycles, epochs of evolution to take place. And for the assumption of the lifetimes, or this communicative lifetime, I propose 3 different lifetimes, 10,000 years, 1,000,000 years, and 100 million years. And I do the analysis for these 3 different time periods to see what the outcome would be. The model I invoke, and this is the model of formation, is a steady state formation and dissolution of technological civilization, as I depict in the next diagram. And I'll go into that. This is a model here, and shows on the y-axis, or right, this is the population of intelligent species and time moving forward. And use my mouse here. This is where we are in the current time. This is where basically the universe presumed to start, and more and more civilizations. We kind of like reached sort of a steady state where civilizations or species are being born and then disappear, being born and disappear. And this little things are the probability distribution, where the number of different aged civilizations are on this axis. Normally you see it horizontally, but I just did it here. And this stays fairly constant all the way along into the future. And even though it may not be the same for billions of years, certainly it's the same for hundreds of millions of years, and from our current time. And that's kind of what I'm assuming here. Now, why haven't, we get into a little thing, why haven't radio astronomers detected alien transmissions? Okay. Well, first thing, the most sensitive radio telescopes can only detect non-directional signals of about 1 light year. The closest stars are about 4.3 light years. And unless the civilization knew about us and directed a concentrated beam of energy directly at us, we could not detect it. And would aliens know about us? Well, the Earth is about radiating electromagnetic signals for about 100 years. This creates a detection sphere, a radius of about, excuse me a minute, I'm gonna stop there. Okay. Detection sphere of about 100 light years. And in this sphere of 100 light year radius, we contain about 720 stars or planets, using average star density in space, which is been figured out currently what that is. We can investigate using statistical modifications of the Drake equation to estimate how many of these planets might have an advanced technical civilization. And it turns out that within that, it's only really about 1 or 0, a low number of, at best, 1 technological civilization within that 100 light years. And advanced technical civilizations, they have better detection schemes, than we have. And so there might be 1 civilization that has detected us, but I'll go on more about this. Would a very advanced technical civilization be interested in looking for other civilizations? Well, that's one I'm going to get into. And here is this diagram shows how I look at it. And I define a detection sphere as, this is a detection sphere of 100 light years. That's where some alien species could possibly detect us with advanced technology, because they might detect our radio transmissions. But as you go farther out, and also there aren't very many technological civilizations. I'd said maybe 1, maybe none. As you go farther out in light years, you get into what I call the time envelope. And the time envelope here, I've defined arbitrarily, I said about 500 light years. And the reason is because I think after having developed for 500 light years, they begin to kind of lose interest in exploration and communicating with civilizations that maybe are less advanced, and they may be more farther out are more advanced civilizations, and they may be more interested in that in investigating them than us. And so Also, as you go beyond 500 years of advancement, their technology may become unrecognizable to us. And one of the reasons I chose the 500 is that, as I said in the beginning, I defined UAPs as machine-like. I still think within a 500-year type of time frame, something in there, that they would still use machines, that we would recognize them as artificial artifacts. And I think beyond that, we may not. They may be, perhaps some of these plasma-like observations are some kind of technology that we really can't categorize. Now, the 500-year radius has about 2 million stars in it, as opposed to the previous one, was the 720, I think. Or, anyhow, has about 2 million stars in it. When we do the statistical analysis of this, we actually get something up to about 170 technical civilizations. That some of these may not all be, some of these actually may be behind us, and like using steam, and many of them may have warp drives ahead of us. So it's not all advanced ahead of us. This is kind of a tough diagram to try and summarize all this, but I took that 500 year radius sphere and basically flattened it down onto a plane, and then I sorted out. I pushed towards us. The green are the civilizations that are within 500 light years, 500 years of our advancement. The reds are farther out and continue on into infinity. And on the left side is the probability distribution. So what I'm doing, this can be calculated based on the assumption of the lifetime. So if we pick a particular lifetime, like say 10,000 years, there will be many more civilizations that are close to us. This is where we are. Then if we pick 100 million years, would be a tiny percentage of the 100 million years. And the number of civilizations that would be within our range would drop off dramatically. In fact, become almost zero. Let's see. So that I can come back to this if I need to. I'm going to skip this one. This is something I'm working on for something else. Okay. This is still a work in progress, and so I'm still doing more. I'm going to be doing more work on this. Okay. What are the implications of a 500-year time envelope? I propose a civilization in advance of us will actually develop interstellar travel capabilities. Sufficiently advanced beyond us may no longer look like machines or be recognizable. And I've said this already, so I won't repeat it. I chose 500 years using a thought experiment. Like if you gave Leonardo da Vinci a cell phone, he would look at it and he would know it's artificial, but totally unable to understand the technology. He might think there was a liquid in there that was giving it the color, and mirrors or maybe gears or something inside it, And further, interstellar travel capabilities will not be remarkable, but a consequence of routine advances in science, and I stated that already. And it assumes that science advances at an exponential rate. And you can kind of see this by, if you compare the advancements between 1800 and 1900, there wasn't, there was some, but it wasn't anywhere near like it is between 1900 and 2000. Or if you go back to the Middle Ages, between 1200 and 1300, just wasn't hardly any changes at all. So it implies we'll develop, it also implies that we will develop a form of interstellar capability in the next 500 years, and probably a lot sooner. Okay, concept of a communicative lifetime. Civilizations that move beyond 500-year time envelope may actually disappear from communicative interests. I mean that they may not travel around as much. They may not be interested in exploring planets. You can imagine if for 500 years you've been exploring the galaxy, you probably have pretty much learned what you're going to learn about species and those kind of things, at least the less advanced ones, and you're going to want to move, maybe begin to investigate your more advanced ones. And also, so the reasons why they might go out, there's lots of reasons, but here are some of them that I think about. They may become distinct. This is the one that is promoted quite frequently. They call it the Great Filter. They may become extinct due to calamity or some type of external supernova or internal shocks like a war. But they may also retreat into a purely intellectual pursuits that become totally self-absorbed. They may move on to pursuits that we can no longer understand. This is, very advanced species, and just as we can't understand, just as ants can't understand international trade relations. It just wouldn't have an idea what's going on. The transhumanists, they propose that we'll merge with machines and retreat into a purely virtual world of some gigantic computer. And finally, another one that may happen is they may become decadent and regress to pre-industrial level. Perhaps pleasure. They have all kinds of ways of entertaining themselves, and just technology. They just drop the technology. Okay. It is highly unlikely that civilization would be near us in technological development due to the age and size of the galaxy, and I've already talked about that before. It says to a civilization 1 million years in advance, we might look like moss on a rock. How about 1 billion years in advance of us? If they could live, if they could be around that long. So what I do is like I said, I explore 3 communicative lifetimes with an average lifetime of 10,000 years, 1 million years, and 100 million years. And I stick with the 500 light year detection radius because of the reasons I said before. And in there, it contained about 2 million stars, and are planets with technological civilizations that are at our level or ahead of us. And I use a statistical equation to do that. This is a kind of a diagram that I was trying to get an idea of how unlikely it is that these civilizations will be any civilization will be at the same level as us. These are all civilizations out there, stars out within the universe, within this time, that some have developed before us, some past, but the green area is only the area that's within 500 years of us. There's a blue area, which I don't show, which is when they're behind us, and that's, I'm not interested in that. And I show a little line here for a few of them that are lined up with us. And these I propose may be the ones that are still in a mode of visiting and may account for some of the sightings that we're seeing, or we think we see. Now I'm back to the R equation, and basically I've kind of covered this, but there's these 6 constants, and the final one is this probability of how long these civilizations will remain communicative. And that's what I use to go ahead and come up with the results that I have for different lifetimes. So what did I use as a database? I mean, in order to do this, I have to, I want to compare what these advanced civilizations that are traveling around. I think they're still interested, and they're traveling around to the local within the 500 light year radius to different stars and periodically investigating other civilizations in there. And the way I look at this is this forms kind of an average traffic intensity for like over a year. That they'll probably get around to us once in a while within a year, and I want to relate this to the number of sightings that we see yearly on a basis. So I had to use some kind of a reference, and there's very few databases, and the databases are really very poor because it's all volunteer, and it's a huge effort to do this. And so what I used was a book called the UFO Sightings Desk Reference by it covers the years 2001 and 2015 by Cheryl and Linda Miller Coster. And I think they did a wonderful job with what they had. It's available on Amazon, and within that, now people will say, well, it's only the United States, and that's true, but it's a place to start. And whatever the sightings are, we can put some multiplication factors for the rest of the world on an average basis, which I'm not doing, but there's plenty of reason why this still would still allow the calculations to be in the same ballpark. So I took a yearly weighted average for over 15 years from the desk reference, and we get about 9,811 sightings per year in the United States. And I had conversations with Robert Powell, who's a senior member of the SCU and a longtime UAP researcher. Robert's been doing this for years, and I really respect his knowledge and insight into this. We have others too, like Rich Hoffman. He also has tremendous experience in this. I don't. I've had an interest, but it's only really been in the last 3 or 4 years I've had time to really pursue this. Well, anyhow, in conversations with Robert, he estimates that maybe between 1 to 5% of the reported cases are valid. And this leads to about 98 to 491 reliable reports per year. But it doesn't mean all of them are UAPs. I mean, some of them, the numbers rather, some of them may be multiple sightings of the same object in different parts of the, they probably don't come here in one spot. And if they do come, they probably don't come here and just stay in one spot. They're moving around, and over some period of time, I would imagine, and you get multiple reports for the same object. The other things too, some of these may be some kind of unknown other phenomenon, natural phenomenon, or something we can't even imagine that just hasn't been discovered yet. So one of the possibilities I might assume is 1/5 of the objects are unique or not some other phenomena. And this would reduce this to between 20 to 98 sightings per year. The calculations that I get predict about 0 to 30 sightings per year. Now, I didn't try and cook the books to make them exactly the same or anything like that. But they're in the same, or I think it's remarkable that they are in the same order of magnitude at all. And there's certainly adjustments. You could increase the you could increase the size of the detection sphere, from 500 or the time envelope. It really is a detection sphere. From a alien species perspective, you could increase this to 1,000 years. It wouldn't massively change because of the nature of the probability distributions. It wouldn't humongously change the the number of objects, but it would probably increase them quite a bit to take into account the differences, maybe even higher number of sightings due to around the world, or those kind of adjustments. And this is all something that can be adjusted in the future. I mean, what I'm trying to do is produce a new way of thinking about this phenomena, and maybe even lead to a new kind of analysis. What I found was that for civilizations with a communicative lifetime of 10,000 years gives about 17 to 170 planets with that we might be in their time envelope, And when I apply to the 17 to 170 planets, the statistical probability distributions, I get the following. This is actually the calculations. This just shows that I didn't just make this up or something, and I've actually done crunching some numbers here. And I used 4 different types of probability distributions. The reason I did that is because while Gaussian is probably the most typical, that's the bell-shaped curve people are familiar with. That's how they grade you in school, those kind of things. The problem we have is that these probability distributions require an average and a standard deviation, which is standard deviation is how wide the curve gets. And of course, you need to know an average to do that. Those are unknown. The averages are what I'm calculating. The standard deviation is something that you have to estimate, and based on different principles. And also, they may be distributed differently than a Gaussian. So I use what's called a uniform distribution, which assumes they're all equally likely, and a log uniform distribution, which has some interesting. It's basically a uniform distribution where the average is the geometric mean of the of the time that the civilization is in a communicative time. Now, this all sounds like mumbo jumbo, but the reason I do that is when you have a uniform distribution is that what it does is the average moves way out to, and also says that a civilization that lives to be 50 million years has the same probability as one that only stayed communicative for 10,000 years, and that just doesn't seem plausible. There's got to be, and almost all processes have a central tendency, and so as you get farther from the average out, there's less probability that it'll occur. So I used 4 different probability distributions for this, and then, I will eventually have a white paper on this, and people that are really interested can dig into it. So. How am I doing here? Looks like I might be running a little long here, but these are kind of the results of my, the investigation that I did. The top table is, again, I said for 10 to the 4th years, the number of, for a communicative lifetime of 10 to the 4th years, which was the major results of the analysis. The other ones don't really hold up. That for in a 1 light year radius, there's like 0 technological civilizations. Well, first, there's technological civilizations. I shouldn't say that. In a 1 light year, there's 0. 100 light years are 720, but they could be ahead of us or behind us. So they might be using water wheels for their technology, and that's a technological civilization that will eventually advance to our level and beyond. Or they may be way ahead of us and have warp drives. And for 100 light years, there's 720 of them. For 500 light years, there's 2 million of them. Now, when I take take into account the lifetime of these and the probability distribution that I get for 10 to the 4th year, there's 0 because of that curve out on the edges of 500 light years out of 500 years out of 10,000 years. In the smaller detection spheres, there's almost 0. There's almost nobody that's that advanced. But when we get to the 500 light years, there's between 17 and 170 using the calculations that I did. And when I plug these in and do the numbers with those previous I showed you, those calculations, what I get is the number of the probability that we would be visited by these civilizations with different lifetimes. So with a lifetime of 10,000 years, we would expect that 5.74% of the 17 to 170 civilizations would possibly be visiting us. For a uniform distribution, for a uniform distribution, we might get 10 a year for that first one. We might get 9 a year for a uniform distribution. For a log uniform, we might get 30 a year. And for a normal, I didn't just talk about the entropy distribution. That's I won't go into that. It's just another important one that well thought of. We might get 17 a year. So all of them are greater than 0 and vary between vary between like the lowest is like 9 to 30 a year. And but for the other times, like a million years, we only get 4 per decade for the first one. We get 9 per century for the uniform. We get 10 per year for the log uniform. That's closer, and 17 per decade for 10 years. For the 10 to the 8th years, we get for the normal, I get 2 per decade. And for the log uniform distribution, we get 9 every 10,000 years. And that may account for some of the biblical stories. Who knows? The log uniform distribution is 6 per decade, and the log normal, the entropy distribution, is 13 per decade. So we know we're getting multiple sightings per year. So it rules out the second two, the bottom 2 rows. And this is what I produced for what I used for my conclusions. So finally, I'll produce a summary here. What I come to is an estimated number of alien civilizations within a. Okay, I've done an estimate of the number. Okay, what has this? What are the results of this study anyhow? First, I've estimated the number of civilizations within 500 light years, and I have a number that might be interested in us, in visiting us, or pass us by now and then. 500 years defines a detection sphere for visiting civilizations, and the number of civilizations, which I've already shown already, is for 100 million years is 0 planets. A million is 0 to 1 planet. 10 to the 4th years is 17 to 170 planets. And yearly UAP sightings are in a rough agreement with results of the calculation. So I'm saying that 0 to 30 sightings is pretty close, and in the same order of magnitude as 98 to 490, which is what 1 to 5% of the current sightings that are seen per year. And I have a divide by n, which we don't know what n is, but it might take into account multiple sightings of the same object, or some kind of natural phenomena that is mistaken, which would reduce those. Certainly not 1. N is not 1. It's something greater, and would bring it closer to this, the 0 to 30. And I'm thinking more like 30. And I think I found it pretty remarkable that it came out like this without having to do a whole lot of, I had to do a lot of work, but I think it's rather remarkable that they're not off by thousands of, or several orders of magnitude, so it encourages me to proceed with this. And if we assume that UAPs are these communicative, intelligent, spacefaring species, is what I define the CIS as. They have a communicative, that we can say that they would have a communicative lifetime of probably no more than 10,000 years. Doesn't mean they disappear, but they will lose interest and go on to other things. There's bigger and better things to do out there than in the future. Finally, all other civilizations that are either too advanced to be interested or are unrecognizable or not far enough advanced to be able to detect us. So one thing is we tend to think that we're very important. We have to understand that someone who's interested in investigating things, there may be a far more advanced civilization. They might be a lot more interested in investigating advanced civilization. And also there's a lot of civilizations that are less advanced, and they might be more interested in visiting them. So we're not this, because of the mediocrity principle, we're not, it's not all that important. We're not that important in the universe. And that concludes my presentation. So I'll open it up to questioning or back to Alejandro. Okay, I'm trying to figure out what's going on here. Okay, stop sharing.
Sorry about that, guys. You couldn't hear me.
Yeah, I can hear you now.
Okay, I'm gonna have to do that to you too, Martin. I forgot whenever I have to show you for a second. And Martin has not made himself look as presentable, so.
Okay.
Look
I hope I didn't.
So the Undead Gaucho, we're going to 5x5 News ask the first question, but I'm going to save that. It's related to one of your previous papers. So I want to ask something related to this topic.
Okay.
Although I'm not sure if you covered this either. The Undead Gaucho asks, why do you believe that there is an anthropomorphic aspect to the supposed occupants associated to UAPs?
Well, I think I don't know if I exactly understand the question.
I think
why do I don't think I make any assumptions about what the UAPs, what the occupants are like, or that I guess maybe what I'm trying to say is I'm proposing that their exploratory ideas are similar to ours. I mean, to the human motivations of why they go around. I think that's maybe what is getting at. And I don't. I do think that intelligence is curious, and the more advanced intelligence is, the more curious it is. But that's leads to exploration and why they may come here, just out of curiosity or to learn something. But as they learn more and more, it drops off in time. I mean, I think that it eventually falls off. So I don't know if I'm answering the question. Maybe they could send it again or something. And
I think you did.
Okay.
Yeah, the next question is from Gaucho. Earth is a good example of evolution, but with the abundance that there could be in the universe, couldn't it be possible that evolution could happen completely differently in a different atmosphere or environment?
Absolutely. Those averages don't assume that the average time for life to form doesn't assume it all forms this is all my opinion, doesn't form in the same way as we do. But in that period of time, some form of intelligent life would evolve. It might it's probably based on carbon, but it may be some other form we haven't, silicon or, something that we haven't derived. But if it's intelligent, it'll have an, I think that the consciousness and intelligence probably is, there may be different forms of consciousness. I don't know, but it probably has similar motivations. It's about all I can say. And so there would be curiosity for some time until eventually that they've satisfied the curiosity and move on to something else. I don't know. That's best I can answer that.
I think that's a great answer. The next question, and I believe they're referring to the Drake equation here. They say the equation assumes that life, intelligence, and civilization can only evolve in a given solar system once. Is there a fix for that?
No, I mean, I think it's maybe even possible in some locations that multiple intelligent species evolve. I don't, I don't have any preconceptions about that. I just think it will evolve, and it could possibly be that a solar system that had multiple planets with life on it. I think we do here. I believe that there's probably life, or had been life, on Mars. I think there's enough evidence now that there's probably is. I think it may be on Europa. It might be on Enceladus. It might be on these moons of these different moons of the planets. But intelligent life is much rarer, I'm sure, and I think that we may encounter life forms that in the future that we can't even imagine. Just look on Earth. If you look at the biosphere, the only intelligent, the anthropods, basically humans and chimpanzees, and going back that line, the only ones that really have good grasping hands and those kind of things, which probably led to the development of intelligence using tools and those kind of things. But there are millions of life forms, quite different. And who's to say that if we'd been wiped out, that some of these might not have evolved into an intelligent, certainly like tentacle creatures like octopus, or where they have a fairly good sized brain, and they're quite capable of manipulating objects. So we might encounter a species sometime in the future that has tentacles. All the reports of visitations by aliens, usually report little gray people, whatever. I think until we get good pictures of this and lots of evidence, I think we should. There's probably having a humanoid form is probably a reasonable adaptation. Or evolutionary development, but there's really no reason why they couldn't have 4 arms or 4 legs, or be something like a horse that had arms to manipulate tools or something like that, or even a centipede, type object. Heaven help us if, we meet something like that, because we're so afraid of differences, just, how all our problems on Earth, with the different racial differences and those kind of things. I think we'd have a lot of problems relating to, something like that. So.
Well, very good. 2 people asked almost an identical question. And does the Drake equation recognize the possibility of multidimensionality?
Well, no, it doesn't really include multidimensionality. It's really just it's like, how many times you throw dice, you can calculate how many times you'll get snake eyes by throwing multiple dice, because the probability of each event, each throw is independent from the next one. And you multiply them together to get the probability of a certain event, how many snake eyes you got out of 6 throws or something like that. And what the Drake equation does is, assuming all the planets that are in our Milky Way, a certain percentage of them, and they're all independent causes. A number of them will stars will form planets. A certain number of those planets will have an atmosphere that's capable of supporting life, and a certain, which is independent of the formation process or where they are. So they're independent probabilities. And then the next probability is of those planets, how many might develop life, which is there's many causes. There may be some dependence, but it's most likely independent. And then how many of those will lead to intelligent life, and then, like that. And you can multiply these together to get a probability of how many planets would have a technological civilization. It doesn't really talk about dimensions or anything, which are, as far as we know, this is the only dimension we have. There's physics, there's like string theory, those kind of things that postulates that there's 10 dimensions, spatial dimensions, but 7 of them are rolled up in a little, tiny little area there that they can use for their calculations and everything. But we don't really have any, as far as I know, any science that really backs up that there are dimensions that spatial dimensions. Time is considered a dimension, but it's not a spatial dimension. And anyhow, it's about all I can say on that.
All right, this one kind of follows up with the previous question, and so everybody knows we are going over a little, but we have a couple more questions we want to get to. Here's the next question by 5x5 News. It seems L and V are the most important as they affect the outcome the most. Would knowing the atmospheres of exoplanets allow for a new variable to bridge that gap?
Well, the Drake equation would include that. That would be one of the parameters in there, is the probability that an intelligent life, that life might form, or that intelligent life might develop. And that would probably be related to the atmosphere, to whether it has a good atmosphere for the development of life and those kind of things. So I used 6 of the parameters I just took from the Drake equation. These are highly specialized areas of study, and they're changing all the time as we learn more and they get more refined. And I didn't want to get into that, because you can look those up, and my equation would just change as those change. And but what I hope my contribution is the lifetime, or the communicative lifetime, of these civilizations can be studied, I think, and theorized, and that's kind of what I did.
Okay, Robert Powell asked this question: if a civilization was capable of traveling faster than the speed of light, couldn't they exist outside of your 500 light year range?
Well, I've seen, once you have interstellar, absolutely. I'm not saying that the civilizations in the 500 light year can't travel. Once they have interstellar travel, I'm assuming that they have some kind of space warping technology, something like in Star Trek, and they can go pretty much anywhere in the universe. So I don't think in my study that there's any limit to where they can go. I'm just saying that their interest would, and I take that kind of into account, that they may be more interested in visiting more advanced civilizations, or civilizations that are on their level than they are ours. And as time goes on, and this, of course, their technology will be such that it's hard to detect. We can barely detect right now planets around other stars, and we're just beginning to get new satellites and stuff that'll be looking at their atmosphere and stuff. But so, they're and there's no limitation. I don't think I have any limitation in what I've talked about that. I hope I understood the question, Robert. We can talk more about it later.
All right, this question is 5x5's first one. I know from seeing online, he's a bit skeptical. He kind of agrees with what's his name, Michael West, or that kind of the skeptical of the objects in the Nimitz event. And so he's asking, using the data in the video, go fast. Please tell us the altitude, if possible, and the speed. I think he's wondering how you determine.
We haven't investigated the go fast. First, that the Nimitz. The reason we did the Nimitz, or I was interested, is because we actually had a reference point. The airplane was traveling at a video of it traveling at a rate, and if once you understand how the flare works and study it, and the readings on the screen, and it's traveling steady, and the characteristics of the camera in the flare. You can then estimate the distance based on Fravor, who said the object was somewhere between a size of an F-18, which is about 56 feet, and we took variations of that. In case there's obviously, when you're looking at something, you make mistakes, and we did the calculations. You can read our paper on there, and we go into it's pretty straightforward. Well, it's sort of straightforward. We go into the calculations and show that the accelerations are enormous. The go fast and the gimbal are more recent events, and I took a quick look at those, and I don't see a good reference for calculating the kind of things I was interested in. And you have to understand, one of these studies, it took us a year, almost a year and 3/4 to do that study. It wasn't something we did in an afternoon. I spent months on this analysis, and Robert and I went over the timeline, and Robert did amazing work interviewing these people, and he interviewed them before this became public in the New York Times. We were actually working on this, and he was, even before I started the SCU, he'd been interviewing these people. So I think our stuff is definitive. And what I talked a little bit with Alejandro about this, that is, as these stories have a half-life, these as time goes on, people talking about them and cross-fertilizing each other with ideas, the stories change. We've seen that the narratives that are developing now are moving in the, not a lot, but some of the details are changing. And so I stand behind the Nimitz. And I don't mind the word. I'm a skeptic myself. I think science should be skeptical, but I'm not a debunker. Debunkers are people that don't analyze anything and just have preconceived ideas, and then just say, well, it's not true because of this, blah, 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 and they don't bother looking at the evidence. So, if we decide to investigate one of these things, then we'll do it. It's a huge effort, and we want to pick and choose what we analyze that will be worthwhile, a return on investment. It's a huge investment in time and energy for a volunteer organization. And so we want to be very careful about what we analyze.
I'm going to combine these two, basically one from Carl and one from G. Vasquez, pronouncing his name wrong. But the mediocrity principle suggests there may be many more like us, with a question mark. And to continue on that, the next following questions: dolphins and whales are intelligent, don't have hands, and don't make tools. Are we limiting ourselves to the anthropomorphic types of intelligence?
Well, I think I addressed that a little earlier in some of the questions. Is that I think dolphins probably have a consciousness. I think my cat is conscious. It's very simple, but it's clear. They make decisions and they think about things, and I can sit there, they're thinking, they have consciousness. It's simpler. A dolphin may be very complicated consciousness. It is a brain, a big brain, and it can, it uses, sonic vibrations to be able to navigate and communicate, and and very intelligent. And I don't limit myself at all. I think that if we were to be wiped out through some event, we blow ourselves up, or there's an asteroid, there probably would be some species that would replace us. I think life is kind of a natural phenomenon in the universe. I think the universe wants to become alive. It seems, in my opinion. Just look at the amazing variety of life on Earth and in weird places, like bottom of the ocean, near getting their energy from volcanoes. So I think that intelligent life will probably be in a lot of forms that will be very surprising, I think.
All right, that is it. Those were all of our questions.
Sorry, I kind of ran over. I could talk for 3 hours on this stuff, but
not a problem at all. Yeah, no problem at all. People were really enjoying it and your answers. So a lot of great information. No problem at all. So for people, if you want to read more, go to the SCU. They can see, Peter, your Nimitz document there. And then, like I said, is this the topic you may be presenting at the next SCU?
Yeah, that's what I'm scheduled for.
Gathering?
A detailed, go with this in greater detail. Present, because some of this stuff is very complicated and takes time to, go through it. But I won't, be doing the equations or anything, but it'll be based on this. And I'm also going to be there's about 8 more months to the conference. I'm going to be developing this even more.
Great. All right, great. Thank you to everybody who joined us and asked questions. A lot of great questions. So thank you all so much for joining us. And keep an eye out, because we will have some more of these presentations going on in the next few months, and even a panel or two, including probably touching on some of these topics that like 5x5 was asking about, some of the calculations behind the videos and stuff. So that'll be a lot of fun. I know a lot of people have questions. So thank you all so much for being here. Thank you so much, Peter, for your presentation. Okay. Everyone can check out explore.scu. We've got some links in the bottom there, and be sure to like and subscribe. Like this video and subscribe to our page if you want to see more video about the science of UAP research.
There's a lot of great information there. So, if you're interested in the scientific basis for this stuff, take a look.
A lot of papers there that can keep you busy for a very long time.
Yeah.
All right. Thank you all very much. Have a great evening.
Thank you.